This is a Math 2 summary video for the lesson titled Symmetries of Quadrilaterals. This is a develop understanding task. The purpose of this lesson is for students to find lines of symmetry and centers and angles of rotational symmetry that carry a figure onto itself. A line that reflects a figure onto itself is called a line of symmetry. A figure that can be carried onto itself by a rotation is said to have rotational symmetry. Every four-sided polygon is a quadrilateral. Some quadrilaterals have additional properties and are given special names like squares, parallelograms, and rhombuses. A diagonal of a quadrilateral is formed when opposite vertices are connected by a line segment. Some quadrilaterals are symmetric about their diagonals. Some are symmetric about other lines. In this task, you will use rigid motion transformations to explore line symmetry and rotational symmetry in various types of quadrilaterals. For each of the following quadrilaterals, you are going to try to answer the question, is it possible to reflect or rotate this quadrilateral onto itself? As you experiment with each quadrilateral, record your findings in the following chart. Be as specific as possible with your descriptions. Let's take a look at a rectangle. We need to find lines of symmetry that reflect the quadrilateral onto itself, and a center and angles of rotation that carry a quadrilateral onto itself. Let's start with the line of reflection. I've went ahead and marked the midpoints of each one of these sides, because if I'm looking for a line, let's start with a vertical line, that reflects the figure onto itself, if I draw a line through the midpoints, that means that I'm guaranteeing that this segment here is congruent to this one, and that this segment is congruent to this one. That means when I reflect the figure over this vertical line, this side length will coincide with this side length. Let's go ahead and perform that reflection. So this isn't the only line of reflection. I also have a horizontal line of reflection. Again, I'm connecting the two midpoints. It's important to be specific in describing exactly where your line of reflection is. Again, the midpoints are significant because if this point right here is the midpoint, that means this segment is congruent to this segment over here, and this segment is congruent to this segment over here. That means when I complete the reflection, the top segment will coincide with the bottom segment. So a rectangle has two lines of reflection. Each line of reflection connects opposite midpoints. For rotational symmetry, we're looking for a center and angle of rotation that carries a quadrilateral onto itself. When I rotate the rectangle 180 degrees, the rectangle is carried onto itself. So the angle of rotation is every 180 degrees. When trying to find the center of rotation, I have a couple of different options. One option is I can look at these lines that pass through the midpoints, and where they intersect is a center of rotation. The other option is I could look at my diagonals. The diagonals in my rectangle are congruent to each other. I know this because when I rotate 180 degrees, they coincide. So this diagonal right here, when I rotate 180 degrees, is now this diagonal right here. I also can tell from my rotation that this intersection point of the diagonals is the midpoint of my diagonals. I know that because when I rotate, they coincide.
With each of these rotations, I'm inadvertently discovering a few properties of the rectangle, but I'm also using what I know about rigid transformations, maintaining congruence, to confirm my ideas about rotational symmetry for rectangles. For each of these rotations, I'm noticing that the center of rotation, which I can describe as either the intersection point of the diagonals or the intersection point of the perpendicular bisectors of the side lengths, it doesn't move. It remains stationary throughout the whole rotation. The center of rotation will be the point that does not move during the rotation because everything is moving around it. To summarize, with reflection symmetry, you need to identify a line of reflection, and with rotational symmetry, you need to identify both a center of rotation and an angle of rotation. Also, make sure that you use appropriate vocabulary and detail in your descriptions. That's it for this video. Thank you for watching.